All right. Let's dive right in. Not much time, but a complex topic, I would argue. So I'm going to talk about network fingerprinting for securing user accounts. What does this mean? But first of all, short, obligatory, who am I? I'm Stephan. Hi, everybody. I lead the security engineering team at 101 Mail and Media. That's a company behind Web.de, GMX, Mailcom, and some of the content of this presentation is from experiences and learnings that I made working there. So without further ado, let's dive right in. Let's talk about protecting users. So when you have users and they have accounts on your website, then you probably start with something like this. So, you know, from anywhere in the internet, anybody can log in using a username or an email address and a password, and you're pretty much bound to get any of those. Like, it's guaranteed. You will get password spraying, you will get credential stuffing, good old brute forcing, all of those things. The question is, what are you going to do about it? Because I hope you're going to do something about it. And now, the question is, you can, of course, do something like rate limiting, and you can ban or lock attackers somehow. You can try to do that, you know, like that would be an intuitive thing. Like, I know your toddler punches your phone a few times and then you have to wait until you can actually unlock it, or you input the PIN 3 times wrong and the ATM eats your credit card, that kind of thing. But the question is what you want to rate limit on or what you want to ban on. And one idea is, of course, on accounts. You can do that. But that really only works if you have targeted attacks. Like somebody's trying out, I don't know, hundreds, thousands of passwords on one account, then you will probably notice this, and you can say something like, I know, this account can't log in now for the next 10 minutes, or has to solve a captcha or something before trying again. So this is something that you can do, but it's not necessarily something that will work if somebody tries to attack lots of different accounts with lots of different passwords. So limited use here. Another idea is on source IPs. It's kind of obvious alternative solution. This does work quite often, but this also has some limitations because there are VPNs, there are NATs, and most of all there are distributed attacks. So your attacker might be sitting behind many different IP addresses and might be a bit of a moving target. So what can you do to detect them? And how can you find out that somebody is the same attacker? Because you might not even notice that it's all coming from the same. You have, let's say, many different IP addresses trying to log into different user accounts with different passwords. How is that an attack? How are you going to notice that somebody is trying to get in? And enter metadata. So you can try to use metadata to detect those attacks and to then try to rate limit them, try to block them, do whatever you want with them. And how does this help you? What kind of metadata are we talking about? This is a typical HTTP request, and what you can see here is that there's lots and lots of metadata. You have things like the method, you have the version, you have all of those headers. The number of headers is metadata in itself. It's a meta information. You have the user agent header here quite conveniently, where the client kind of gives away what they are. But we will get to that one later because it can be faked easily. And of course, you have cookies, and how many cookies are there, which cookies, and so on. And when we're talking about websites, we typically talk about HTTPS these days, so you have TLS. So you also have metadata on the TLS level. This is a screenshot from Wireshark from the client hello package, so part of a TLS handshake. And what you can see here is also lots of metadata. So you see the versions that are supported by the client. You see things like the cipher suites, the extensions, whether or not it supports ALPN, those kind of things. All of this is metadata as well, and this can help you in trying to figure out, you can try to distinguish different clients based on what kind of metadata they have, like which kind of extensions do they support, for example. There's more metadata that you could theoretically use, gets then more involved and more specific, like for example, when you have TCP, or also QUIC, then you have things like the duration between the steps in the handshake. So how long does it take in between packages? That's a bit advanced and goes a bit far now. Also in HTTP2, you have, for example, the frame sizes can be different. Today I'm going to focus on generic HTTP and on TLS for brevity's sake. So, what are fingerprints then, and how does all of this metadata help us? So what can I do with it to get it from, okay, metadata is there, to I can actually condense this into something. This something is going to be a fingerprint that I can actually use. And I'm going to show you some standards or open specifications for fingerprints. One that is super common is GA3. This was developed at Salesforce. It's no longer supported or maintained in that sense. That's no longer being evolved, but it's supported by various tools. And it uses fields from the client hello package, like the one that I showed you before. These are all of the fields that go into such a fingerprint. They are just taken directly from the client hello, so the byte values are taken as a decimal representation, concatenated MD5 hash over it. That's it. This is a screenshot directly out of Wireshark. So Wireshark, for example, supports GA3. By the way, it's GA3 because the three inventors or people that worked on it all had names starting with J and A. It's John Althouse, Jeff Atkinson, and Josh Atkins. So there's no J1 or J2, from what I know at least. Afterwards, one of those, John Althouse, left Salesforce, started his own company called Fox.io, and started and continued working on the fingerprint topic, and created JA4. This time, this is an increment, so I don't think he found another person with JA as initials. And he continued this work and created the JA4 Plus suite, which is a list of various methods, which is a bit confusing because JA4 is one of those. JA4 is TLS fingerprinting, but there's other ones. There's, for example, also for HTTP, for TCP, SSH. All of those can become quite handy depending on what you do. There's also for client and for servers, like you can, for example, create fingerprints on the information that a server would give up. Like servers that have a TLS certificate will share their meta information, of course, with you if you're trying to connect to them. And you can create a fingerprint, and this way you can, for example, identify command and control servers that belong to the same group, for example. But for protecting users and looking at users on web pages, we're going to focus on TLS and HTTP. Licensing note, only JA4 itself is licensed under BSD, so that one's basically free to go. The other ones are published under the Fox.io license, which is one of these partially commercial, partially open licenses, so you can use it in an open source tool, and you can use it internally in your business. But if you want to build a product on it and sell it basically as a product, then you would have to reach out to Fox.io for a license. So this here taken directly from Fox.io with the permission of John Althouse, who, by the way, is super approachable and super responsive. I wanted to create such a thing, and in the end it would have ended up looking exactly the same as on his page, so I just use his version. As you can see, this is everything that goes into a TLS fingerprint of JA4, following the JA4 specification. And you see all the fields, like you have, for example, the protocol, TLS version, SNI, number of cipher suites, number of extensions, and so on, you can read. And you end up with this fixed length string, which is arguably kind of human readable. Like you could read it if you have this picture somewhere on the side, and you can see, okay, this means that, and you can parse it back, something that wasn't possible with JA3 because MD5 hash, and not something you can put back into a tool if you wanted to. Another one that I want to show you, this is JA4H, which is then an HTTP client fingerprint. Again, lots of the metadata that we saw before on the HTTP request goes here into this fingerprint. So you can see all of it, method, version, cookies, if they're not there or not, if there's a referrer or not, and so on and so on. So again, a fixed length fingerprint with a standardized format. So if you can get these kind of fingerprints for a request or for a client connection, then you can try to correlate this with, this might be an attacker, or there are many different requests coming in from different IP addresses on different accounts, but they all share the same weird fingerprint that does not look like the typical, I don't know, Chrome on Windows fingerprint. This is super suspicious. Maybe I need to, I don't know, block them or rate limit them or do something about it. I wanted to talk about technical challenges. This is really one of the main topics of this talk. So let's go on this one. I created kind of a sample setup. Of course, depending on your company, this will look completely different or very much the same. I think this is a reasonably common setup that you see quite often. You have clients that connect to your infrastructure, in which you have something like a TCP load balancer maybe in the beginning, reverse proxy, and then some kind of service that you created, web application, and then maybe there's more behind, lots of microservices, whatever you do. But this is not uncommon. Maybe sometimes these two are the same, depends. But for the sake of this presentation, let's think that this is our setup. Now, one way of creating fingerprints is that you do it out of band. That means you have your request that just goes through here, through this chain, but you are kind of snorkeling here. This is supposed to be a diver's goggles. excuse my art, let's call it that. But you can kind of try to get the traffic out here. It's one possibility. You can try and get it out there. So different ways of getting it out, but you have to figure out what's the best way. This depends a lot on your infrastructure and might be really tricky or quite easy. And now you got all this data out and dumped it somewhere, I guess. And now you have to make a decision in your service whether or not this request is legit, or you want to make the decision somewhere else. But somehow you have to correlate the request that you tracked before back to the request. You kind of have to do the matchmaking here, which you have to also solve. I'm not going to give you solutions today because this will be super dependent on your setup, of course. But some of the things you need to think about before you start implementing it. Another option is you do it in stream. So basically, within this login path, for example, or any kind of request, you can try to take yourself onto the request, which raises a few other questions. Like one is, where is the TLS handshake happening? Where is the TLS offloading? Because only where you do the TLS offloading, you will have access to the client hello package that you will need if you want to use TLS metadata, at least some of it. Another challenge will be, are these things here extensible depending on what you use? Like typically you're not going to do your own TCP load balancer or reverse proxy, but you will probably use something like a commercial solution, open source solution, like Nginx, HA proxy, whatever. But the question is, can you actually go in and create a fingerprint somehow? And the next question is, how do you then get the fingerprint to the back here? Like you can add metadata in a reverse proxy quite easily because you're on the HTTP layer, on the application layer. So you can just add it as HTTP headers. But it's really tricky here if you're really talking about only exclusively TCP. You can't really add metadata to a TCP request, at least not super easily. You know, there's things like the proxy protocol by HA proxy, but that only adds a header, like one header for a source IP. So you would have to kind of roll your own thing here. So one suggestion, one idea of how to do it, this is one that I think is quite realistic to achieve, is that you do it in the reverse proxy. If you have one that is extensible enough, I will get to that later. So you can do your TLS offloading here. Most reverse proxies can do that. You can, of course, then re-encrypt on the way to your backend. And you have access to your HTTP request and the meta information there. And then you can edit as fingerprints as headers on your request, and then use them for decision making later. And so I wanted to show you what this can look like. This is one suggestion. Let's say you're using something like Traffic, really common reverse proxy in the Kubernetes world as an ingress controller, and written in Go, and you can add plugins there, also written in Go, and conveniently in Go, you can create something called HTTP middleware that is just has to implement this function here. And you get a response writer and a request. And here you have all of this information. So thinking back to the previous slide about JA4H, you have everything here. Like you have the method, version, cookies, and so on and so on. So you can easily create a JA4H fingerprint valid one using all of this. So that's definitely possible in the example of Traffic. This may or may not apply to your reverse proxy depending on which one you use. But on the other hand, an attacker can also manipulate all of this data. This is an example, again, in Go, to kind of stay consistent. As you can see, it's not super hard to manipulate most of these values. Like you can force the version that your client is going to use. You can, of course, manipulate all of the headers. Like the user agent header is just a header. You can say, hey, I'm Chrome, whatever, on something operating system. And you can, of course, add cookies however you want. So you can try to mimic legit traffic. This is the same in curl, even shorter, even easier. So yeah, you can set everything basically that you will need. So this doesn't mean that it's worthless to do it, but the cost that you will have is low, as you saw, quite easy to be done. But the cost on the attacker side is also not that high. The same for TLS fingerprinting. There's an attempt at doing the same thing, again in the hypothetical setup that you might be using Traffic. This is what it will look like, and you will realize that you can't do a full JA4 fingerprint. Not possible, at least not without forking Traffic. or contributing back as well, because the client hello happens much earlier before any of the plugins are called. So you don't have some of the information here. You only have the negotiated Cypher suite. You only have the negotiated version. You don't have all the Cypher suites that a client supports, or all the extensions that a client supports at this point anymore. So with traffic, you're not going to be able to create a full GA4 fingerprint. You will need to use a different proxy, for example. Question is if you can. This is what a client could do. So you could manipulate this in curl. This could look like this. Some of the things you can set, like for example, the TLS version you can set. But some things, like for example, extensions, you can't easily manipulate on the level of your curl command line flags. You would have to go down into OpenSSL, Boring SSL, whichever one it uses on your platform, to do it on that level, which becomes much more intricate and much more effort, of course. So kind of hard for you to get the information as a defender, but also kind of hard for an attacker to manipulate the metadata on this level and try to mimic being something that they're not. I skipped the Go example. It's doable in Go, but not with a standard library from what I know at least. There are third-party libraries that let you manipulate this meta information, but it would have become way too long for one slide, so I skipped it. Another technical challenge, kind of a bonus round that I thought about after in the run-up to creating this presentation. I looked at some of the implementations, including the sample implementations of J4 by Fox.io, and you have a lot of these fields here, number of something, number of Cypher suites, number of extensions, number of headers in J4H. And what you don't see from here, in the specification, is kind of slim on the official repo. These are always 2 digits, so you have to left pad them with zeros, and if you run over 100, you have to cap them at 99. So it's kind of a gotcha you have to be aware of. Realistically, like in a realistic scenario, this should probably never be more than 99, or even much lower, but something to be aware of. So take care of input validation. So these are some of the technical challenges you will face. And just to quickly touch on them, there are also other challenges. Organizational challenges can occur depending on your organization, such as these different components might be owned by different teams. And these teams might have completely different managers, different priorities, might be working on in different setups, in different locations. So there's lots and lots of possibilities of this becoming an issue or not. Like people here that work for small companies might be laughing, people that work for big companies might not be laughing. So it really depends on your setup here again. You also have the potential here that teams might not get along. So on a very human level, there's something to be aware. So if you want to do something and use something like fingerprints, think about who your stakeholders are and who you need to get buy-in from at which point, so you can get this on the road. And of course, there are regulatory challenges, elephant in the room, GDPR. When you do fingerprints, I mean, it already has the name of these here on your hands. They are not as unique as the ones on your hands, but they are possibly personally identifiable information, PII. And you might not be allowed to, for example, store them, at least not for a longer time period. So retention times might be important to figure out here. Definitely something that you want to talk about with your data privacy officer, because this can really get you into hot water. So summing it up, I showed a few challenges, some of them bigger, some of them less big, depending on many factors. So the question is a bit if it's still worth it to implement something like fingerprints, and I would say probably yes, kind of a depends answer. I think it does make sense if you can avoid being an easy target and if you can drive up the cost for attackers, because that's ultimately what you want. You want the attacker to say, this is too much effort, this is too expensive, I'm moving on to another target. And that's it. I think I'm on time. Thank you.
Questions? Okay, there's one.
One question from me would be how, looking at the TLS fingerprinting, how likely is it that latest version of Windows, latest version of Edge looks exactly the same for everyone who has that latest version? Is it still good to distinguish scripts from real users when every real user looks the same?
I would argue that yes, because, for example, let's say you use a script, then you will again, it depends on the answer. I know this is stupid, but like depending on the library that you're using, if you're using, for example, curl in your script, or you're using, let's say you're doing it in Python, you're using requests, then they will often have a distinct set of various characteristics that they will send, and that will allow you to distinguish them from like real user browser traffic. So I think you can still use this quite a lot, but of course, like it's not a silver bullet. You will have to use it together with other data points and other information to correlate it somehow.
Good. I think over there's another question. I run over. This is after lunch.
Thank you for the talk. One question regarding how do you respond to whatever you may detect if you come to the conclusion it looks like it is an attack. So any kind of response that you suddenly drop it, answer it somehow, might give back some information to the attacker, and the attacker might adapt to it. Are there any best practices you could recommend, or is it intellectual property of your company?
The jury is still out on that, so we're also still learning on that. And yeah, I mean, some attackers are persistent and will play the cat and mouse game with you. Some attackers will relent and not attack you anymore. So no easy answer here, unfortunately.
Okay, more questions? I have one, so okay, you want first? Or? Okay, good. Is there any JA library which is free for use, especially with GPL programs?
Not that I know. And so there are the default implementations that are published by Fox.io, but those are for out-of-sync fingerprint creation. So you create a PCAP file, you give the PCAP file to, there's a Python implementation and a Rust implementation, and you can throw the PCAP file at it and it will create fingerprints for you. But I don't know any libraries where you can just say, okay, here's a client, hello, create a fingerprint for me.
How does it work with Wireshark? Because they're doing JA3. That's also restrictive, right?
I don't know, honestly. Actually, no, I think JA3 is completely open sourced under BSD license, but don't take my word on it.
Is it in the meantime? Because I was on GitHub, and every time somebody did a PR, like when the project was still alive, you have to sign the agreement for us.
Ah, okay.
It was kind of strange.
Not sure. No idea on that. Sorry.
Good. Thank you.
Yeah. Thank you for the talk. Can you please go to the slide 1 to back when you introduced the technical architecture? Yeah, this one. Yeah. So the problem here is that you would need to synchronize what the TCP load balancer, the HTTP errors, proxy, and so on does. This reminds me also on the scenarios where in China, for example, they use censorship and so on. So what they do, instead of analyzing on the fly, they inject like TCP resets inside. So have you thought about this, like instead of like analyzing it, so this helps you like also to prevent this analysis on the fly and makes it more like robust, and you can have different perspectives on this and
thought about it, yes. Again, jury's still a bit out, like this is a work in progress. Regarding, so yeah, you can do so, for example, you can stop a TCP session, and this is like goes both ways, right? An attacker can end the TCP session and try again, but you can also use it for your defense by dropping an open session and then forcing a client to reconnect. Depending on the client, this might drive up the cost as well, because okay, it doesn't cost much to do a TCP handshake, but it costs a little bit, and you slow down your attacker like that. But yeah, these are aspects that then also go into it. So it's a rabbit hole.
Okay, another questions? No, there's no question. Then I might have another one. Would it also make sense to track fingerprints from the inside to the outside, so that you know
Definitely.
if your network boundary crosses something from the inside, which seem to have a malicious JA whatever fingerprint?
Yep, absolutely. Yes. So this is very widely applicable. You can use this. Like in my example, I only showed on how to use this for attack detection on a typical web API, but you can use it, like for example, there's also a fingerprint methods, or you can come up with your own fingerprint method for SSH traffic, for example, or like outgoing traffic to a server. So yeah, you can use this also, for example, for intrusion detection, like anything that communicates on your network that is not supposed to, and that looks different than anything else, could raise an alert, for example.
Okay, thank you. More questions? Okay, if that's not the case, then let's thank again Stephan for the great talk.
Thank you.